Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content. Welcome back to ReneEnergy.com's YouTube channel. In our previous video, we discussed the integration of resource assessment results into comprehensive feasibility analysis for green hydrogen projects. Today, we'll dive into a crucial aspect of resource assessment that is often overlooked but plays a critical role in project decision-making: uncertainty and risk analysis. Green hydrogen projects, like any other renewable energy ventures, are subject to various uncertainties and risks that can impact their technical, economic, and environmental performance. In this video, we'll explore the importance of uncertainty and risk analysis in green hydrogen resource assessment, and discuss the methods and tools used to quantify and manage these factors. Uncertainty in resource assessment refers to the inherent variability and unpredictability of renewable energy resources, such as solar irradiance, wind speed, and water availability. These resources are influenced by complex atmospheric and environmental processes that operate at different spatial and temporal scales, making their accurate characterization and forecasting a challenging task. Uncertainty can arise from various sources, including measurement errors, data gaps, model assumptions, and natural variability. For example, in solar resource assessment, uncertainty can stem from the accuracy and calibration of the sensors used to measure solar irradiance, the interpolation and extrapolation of data from nearby stations, the selection of appropriate models to estimate solar potential, and the year-to-year variability of solar radiation due to climate factors. Similarly, in wind resource assessment, uncertainty can arise from the accuracy and representativeness of wind speed measurements, the extrapolation of wind data to hub heights, the choice of wind flow models and turbulence parameters, and the long-term variability of wind patterns. Risk, on the other hand, refers to the potential negative consequences or impacts that may result from the uncertainties associated with a project. Risks in green hydrogen projects can take various forms, such as technical risks, for example, equipment failure, performance degradation, economic risks, for example, cost overruns, revenue shortfalls, environmental risks, for example, ecosystem damage, water scarcity, and social risks, for example, community opposition, permitting delays. These risks can have significant implications for the feasibility, profitability, and sustainability of the project, and need to be carefully assessed and managed. The process of uncertainty and risk analysis in green hydrogen resource assessment typically involves several key steps. The first step is to identify and characterize the sources of uncertainty and risk relevant to the project. This involves a systematic review of the data, models, and assumptions used in the resource assessment, as well as a stakeholder consultation to understand the concerns and priorities of different actors involved in the project. The second step is to quantify the magnitude and likelihood of the identified uncertainties and risks. This is often done using statistical and probabilistic methods, such as Monte Carlo simulation, which involves running multiple iterations of the resource assessment model with different input values sampled from probability distributions. The results of the simulation provide a range of possible outcomes and their associated probabilities, allowing project developers to assess the sensitivity of the resource estimates to different uncertainties and risks. For example, in solar resource assessment, a Monte Carlo simulation may involve varying the input parameters such as the sensor accuracy, the interpolation method, and the solar model coefficients, and generating a distribution of possible solar irradiance values for each location and time step. This distribution can then be used to calculate the probability of achieving different levels of solar energy production, and to identify the most influential uncertainties and risks. The third step is to evaluate the potential impacts and consequences of the identified uncertainties and risks on the project outcomes. This involves translating the quantified uncertainties and risks into technical, economic, and environmental metrics that are relevant to the project's goals and constraints. For example, the uncertainty in solar resource estimates may be translated into the variability of the expected energy yield and the associated revenue streams, while the risk of water scarcity may be translated into the potential impacts on the electrolyzer efficiency and the hydrogen production costs. The fourth step is to develop and implement strategies to mitigate and manage the identified uncertainties and risks. This involves a proactive and adaptive approach that combines technical, financial, and institutional measures to reduce the likelihood and severity of negative impacts, and to enhance the resilience and flexibility of the project. For example, technical measures may include the use of advanced sensors and monitoring systems to reduce measurement uncertainties, the selection of robust and reliable components to minimize performance risks, and the incorporation of storage and backup systems to buffer against resource variability. Financial measures may include the use of insurance and hedging instruments to transfer and share risks, the negotiation of favorable power purchase agreements to ensure stable revenues, and the diversification of funding sources to reduce exposure to single investors or markets. Institutional measures may include the engagement and consultation with local communities to build trust and support, the compliance with relevant regulations and standards to minimize legal and reputational risks, and the collaboration with research and industry partners to access cutting-edge knowledge and technologies. Case studies from around the world demonstrate the value of uncertainty and risk analysis in green hydrogen resource assessment. For example, the Hydrogen Park South Australia project, which aims to produce green hydrogen from a mix of wind, solar, and grid electricity, conducted a detailed uncertainty analysis to assess the variability and reliability of the renewable energy supply. The analysis used historical data and numerical weather models to simulate the hourly variability of wind and solar resources over a 20-year period, and to estimate the probability of meeting different levels of hydrogen demand. The results of the analysis informed the design and sizing of the electrolyzer and storage systems, and helped to optimize the operation and dispatch of the hydrogen production facility. Another notable example is the Hellas project in Norway, which aims to demonstrate the feasibility of green hydrogen production and storage in remote and off-grid locations. The project conducted a comprehensive risk analysis to identify and assess the technical, economic, and environmental risks associated with the deployment of wind turbines, electrolyzers, and fuel cells in harsh Arctic conditions. The analysis used a combination of expert elicitation, scenario analysis, and multi-criteria decision-making to prioritize and mitigate the risks, and to develop a roadmap for the safe and sustainable implementation of the project. The results of the analysis informed the selection of the most appropriate technologies and business models, and helped to secure the necessary permits and stakeholder support. These case studies highlight the importance of uncertainty and risk analysis in green hydrogen resource assessment, and demonstrate the value of using rigorous and transparent methods to quantify and manage these factors. By incorporating uncertainty and risk considerations into the resource assessment process, project developers can make more informed and robust decisions, and can enhance the bankability and resilience of their projects. As we look to the future, the role of uncertainty and risk analysis in green hydrogen resource assessment is likely to become even more critical, as the scale and complexity of projects continue to grow, and as the impacts of climate change and other global challenges become more pronounced. Emerging trends and technologies, such as the use of artificial intelligence and machine learning for data-driven uncertainty quantification, the development of blockchain-based risk management platforms, and the integration of multi-sectoral and multi-regional planning tools, are expected to provide new opportunities for enhancing the accuracy, transparency, and effectiveness of uncertainty and risk analysis in green hydrogen projects. In conclusion, uncertainty and risk analysis is a crucial component of green hydrogen resource assessment that should not be overlooked or underestimated. By systematically identifying, quantifying, and managing the uncertainties and risks associated with renewable energy resources, project developers can enhance the feasibility, profitability, and sustainability of their green hydrogen ventures, and can contribute to the accelerated deployment and scaling up of this promising technology. As we continue our journey through the world of green hydrogen resource assessment, we invite you to stay tuned for the next video, where we'll explore some inspiring case studies of successful green hydrogen projects from around the world. Don't forget to like, share, and subscribe to ReneEnergy.com's YouTube channel for more exciting content on renewable energy and green hydrogen. Until next time, stay curious and keep exploring the possibilities of uncertainty and risk analysis in green hydrogen development. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.